Hello students, welcome to my journey through haloalkanes and haloarenes, and today we will have an introduction to haloalkanes and haloarenes. So what are haloalkanes and haloarenes? Alkanes with a halogen atom are called haloalkanes and arenes with a halogen atom are called haloarenes. Now what are these alkanes and arenes? They are nothing but hydrocarbons. Hydrocarbons are the compounds containing carbon and hydrogen like CH4, methane, CH3, CH3, ethane, CH6, benzene, etc. So, in 11th standard, you might have learned the classification of hydrocarbons into aliphatic and aromatic hydrocarbons. So, aliphatic hydrocarbons are the compounds with a straight chain or with branching. So, straight chain or branching hydrocarbons are called as aliphatic hydrocarbons, and you can see some examples here. That is, here you can see there are 3 carbon atoms and 3 carbon atoms, each one is attached to different hydrogen atoms, and it is a straight chain. There is no branching, all are straight chain carbon atom, and it is called as propane. In this example, you can see the second carbon atom is attached to one more carbon atom. So here you can see a branching. This is also an aliphatic hydrocarbon. And aliphatic hydrocarbon can also be classified as alkane, alkene and alkynes. So alkanes are aliphatic hydrocarbons. And now what are aromatic hydrocarbons? Aromatic hydrocarbons are a closed structure like benzene with alternate single and double bond. And other examples are of aromatic hydrocarbons are naphthalene, anthracene, phenanthrene, toluene. All these are aromatic hydrocarbons and they have pleasant odor. Aroma means smell. So aromatic hydrocarbons are structures like benzene which have alternate single and double bond and they have pleasant odor. So arenes are aromatic hydrocarbons. So alkanes are aliphatic hydrocarbons and arenes are aromatic hydrocarbons. Now let us see how are haloalkanes and haloarenes formed. They are formed by the replacement of hydrogen atom or atoms in a aliphatic hydrocarbon. It will result in the formation of haloalkane, and replacement of hydrogen atom or atoms by halogen atom or atoms in an aromatic hydrocarbon will result in the formation of haloarene, or also called as aryl halide. Now we'll just see through an example. Say haloalkane. Consider the simplest alkane CH4, which is called as methane. Here there is one carbon atom. Carbon is tetravalent. It is attached to 4 hydrogen atoms. Now, if it is treated with chlorine in presence of sunlight, it will replace one hydrogen atom with a chlorine atom. Okay, so it will result in CH3Cl. So this is alkane. CH4 is alkane. When it loses one hydrogen atom, it becomes CH3, that is called as alkyl or otherwise called as methyl, and halide or halogen atom is here, so it is called as methyl chloride, or otherwise it can also be called as alkyl halide. That is how haloalkane get the name alkyl halide. One alkane is, from one alkane, one hydrogen atom is replaced by a halogen atom. It becomes alkyl halide or otherwise called as haloalkane. Further, when it goes reaction, it can replace hydrogen atoms forming CH2Cl2, dichloromethane. Further, if it goes reaction, it forms CHCl3, chloroform. Further, it can remove one more hydrogen atom which is present by halogen atom. It will form CCl4 or tetrachloromethane or carbon tetrachloride. So this is how haloalkane is formed. So a haloalkane is formed by the replacement of hydrogen atom or hydrogen atoms by halogen atom or halogen atoms. So this is how haloalkane or alkyl halide is formed. Now coming on to haloarenes, you can see simplest arene is benzene, C6H6. There are 6 hydrogen atoms that can be replaced. If you replace one hydrogen atom with a halogen atom, it will form C6H5X. Further, if it goes reaction, it will form C6H4X2. And on drastic conditions, it can undergo reaction like this, where all the hydrogen atom will be replaced by chlorine atoms. That is benzene hexachloride it can form. So this is how haloarene is formed. That is by the replacement of one hydrogen atom by a halogen atom, or hydrogen atoms by halogen atoms. So this is how haloarene is formed. So once again, haloalkane and haloarenes are formed by the replacement of either one hydrogen atom or hydrogen atoms by halogen atom or halogen atoms. That will, if it is an aliphatic hydrocarbon, it will result in the formation of haloalkane, or otherwise called as alkyl halide. And if it is aromatic hydrocarbon, it will form haloarene, or otherwise called as aryl halide. Now we'll see what is the structural difference between haloalkane and haloarene. In haloalkane, it is alkane. All are single bond. There is no double bond or triple bond. So the halogen atom is attached to carbon atom, which is sp3 hybridized. So in a haloalkane, halogen atom is attached to carbon atom, which is sp3 hybridized. In haloarene, I told you, arenes, they have alternate single and double bond. So the halogen atom is attached to carbon atom, which is sp2 hybridized. That is the simplest structural difference between haloalkane and haloarenes. In haloalkane, halogen atom is attached to carbon atom, which is sp3 hybridized, and in haloarene, halogen atom is attached to carbon atom, which is sp2 hybridized. And these haloalkanes and haloarenes are extremely useful compounds. They can be used as the starting material for the synthesis of many other organic compounds, and several of them can be used as drugs. Examples are chloramphenicol, chloroquine, which you now often hear. It is used in the treatment of malaria. There are other haloalkanes and haloarenes which are also very useful. So this is just an introduction to haloalkanes and haloarenes. Hope you have understood. If you find this video useful, please share it, like it, and subscribe. Thank you.